How's it going out there at Global Hack Week? Happy to see you again. Once again, it's Rosendo from MLH. Today, we are going to keep all of the content rolling. We've had some awesome workshops so far today. You've learned everything about vector search, RAG applications. You've even learned how to use an AI coding assistant to build out an application on the web. So now what we're going to do is we're going to start with Oracle machine learning and see what we need to get started learning about that. If you want to register and check in for this workshop, the link is right there below. Make sure you do so you get credit for being here. And if you're excited to learn a little bit more about what Oracle has to offer, definitely let us know in chat. Today, we've got two great presenters that are actually going to come up and introduce themselves momentarily. I will not spoil the fun for you, but please give a warm welcome to Mark and Sherry from Oracle.
Okay, great. Well, thank you, Horizonte. Welcome to this session on getting started with Oracle Machine Learning on Autonomous Database. I'm Mark Hornick. I lead the in-database machine learning and select AI product management, and I'm joined by Sherry LaMonica. Sherry, please introduce yourself.
Hi, everyone. I'm Sherry LaMonica. I'm a consulting member of technical staff in the Oracle Machine Learning Product Management Group at Oracle.
Great. In today's session, we're going to give you an overview of Oracle Machine Learning on Autonomous Database, with the focus being on the Oracle Machine Learning Notebooks environment. Now, since we'll be using Oracle Machine Learning on Autonomous Database, you've probably heard a little bit about that, but I'm just going to briefly introduce it to set the stage for that. So, you can think of Autonomous Database as Oracle Database reimagined for the cloud. Automates the database management lifecycle, providing mission-critical database support using performance-engineered systems, and folding in database management best practices, AI, and powerful data tools. Now, Autonomous Database makes it easy to use powerful database management technology and a host of other built-in capabilities. Now, Autonomous Database provides a wide range of tools, and these are built right into the platform, whether you're interested in notebooks, REST services, low-code application development, vector database capabilities, as you've heard earlier today, data analysis, and machine learning, graph, and spatial analytics, along with plenty of others. And it's worth noting that in the multi-cloud environment, you have deployment choices, whether you're using OCI, Azure, Google, AWS, or others for running Autonomous Database. But the focus of today's session is Oracle Machine Learning and the built-in notebook application. Now, before we get into the features of OML notebooks, let's start with an introduction to Oracle Machine Learning itself. With OML, we've placed powerful machine learning algorithms directly in the database, which helps you develop and deploy solutions quickly for applications and dashboards. With OML, you get to explore and transform your data, as well as build and use machine learning models directly in the database. There are a few advantages to this. OML eliminates costly and potentially risky data movement for database data. And it avoids requiring separate analytical engines, producing a simpler solution architecture. There's less to manage and less to test. OML gives you over 30 scalable in-database algorithms accessible through multiple language interfaces, including SQL, Python, and R, which you can use in OML notebooks. It's also easy to use OML in tools like Oracle Apex. Now, for those of you who might be concerned about cost, OML is included with Autonomous Database instances and Oracle Database licenses, so you can just start using it. Now, Oracle Machine Learning is a relatively mature product. It's evolved over more than 2 decades, and we started with the acquisition of a company called Thinking Machines all the way back in 1999. And as you can see here, we've continually enhanced the machine learning capabilities available in the database, and we'll introduce several of these in this session. But first, let's ask the question, what types of business problems or use cases can you address with machine learning? You often think of industry-specific vertical use cases, but there are surprisingly many that cut across industries, what we'll call horizontal use cases. Most enterprises have customers, products, equipment, and employees. And here we see a range of use cases that we could apply to customers, from customer segmentation and churn prediction to lead generation and fraud detection. For products, what product should we recommend to our customers? Perhaps we want to forecast demand, inventory, and revenue. On the equipment front, consider predictive maintenance. we service equipment too soon, we're likely wasting money. But if we service it too late, we could incur much more expensive repair costs or even need to replace the equipment. And finally, employees. What are the attributes of our best employees? Can we predict which are likely to leave or what our hiring needs are going to be? But these use cases can be addressed using a range of machine learning techniques. We'll start with, say, classification. This is a technique where we can use, for example, predicting customers with high lifetime value or who are likely to prepay their loan from a banking customer, or perhaps default on their loan. Other use cases can include predicting which vehicles need maintenance, whether a customer is likely to churn, or which customers we should prioritize with marketing campaigns. Now, another technique, regression, could be applied to some of these same classification use cases, but adapted to predict a numeric outcome. For example, let's say instead of predicting customer lifetime value is high, medium, or low, we actually want a monetary value that could be summed. Other regression use cases include forecasting product demands, sales, or revenue. But these same use cases could be applied for time series. It has another class of algorithms, and that depends on how the data is organized as to whether or not you would use time series over regression. Now, clustering helps with customer segmentation and document classification, which can overlap with the classification technique. Association rules help identify cross-sell and upsell opportunities, and anomaly detection is useful for transaction or claims fraud detection, or just identifying unusual cases, which may signify the need for closer inspection of your data. And these examples, of course, just scratch the surface of what's possible. Now, OML supports the use cases just highlighted and plenty of others by providing a rich set of algorithms across multiple machine learning techniques. Now, you might ask, why do we have multiple algorithms for a given technique? Well, some algorithms are better at finding certain types of patterns than others. Some offer a greater degree of transparency to understand those patterns, the insights that were discovered. And each has its own computational demands, meaning that some are faster than others. But what makes these algorithms different from those that you can get from open source packages or other vendors? It's a good question. Well, there are a few differentiators. In-database parallelized algorithms. Well, that means that there's no need to extract data to separate machine learning engines, which can be time-consuming and affect performance and data security. These algorithms have been reimagined, redesigned, if you will, to offer scalability across cluster nodes and optimize memory use by not requiring all the data to be loaded into memory to build models. Scoring, or also known as inferencing, can take advantage of the Exadata storage tier function pushdown optimizations for even faster scoring, especially for large batch scoring jobs. Now, in-database machine learning models are also first-class objects in the database. And that means that, like database tables, you can control access by granting and revoking permissions, auditing user actions, and exporting and importing models across databases. Once you build a model, it's immediately accessible through SQL queries. And as a database object, models are part of database backup, recovery, and security. As a result, it can be much faster to deploy machine learning-based solutions. You can use prediction operators in SQL queries, make predictions from R and Python, and deploy models using no-code and REST interfaces. So this table just gives a quick summary of the OML components and where they're available. Note that all of the components listed here are available with Autonomous Database Serverless and Dedicated Region. You'll be working with Autonomous Database Serverless. And as we've already noted, OML provides support for in-database machine learning from the top 3 data science languages, SQL, R, and Python. Now, for OML for SQL, this enables building models using a PL/SQL interface and scoring data, or inferencing, using SQL queries. More recently, it also allows you to import ONNX format models to the database for use from SQL queries, leveraging the in-database ONNX runtime. Now, OML for R and OML for Pi allow you to manipulate data and build machine learning models directly in the database using data frame proxy objects with native R and Python syntax and functions. You can also invoke user-defined R and Python functions in database spawned and managed engines, even invoking R and Python user-defined functions from SQL and REST. Now, Autonomous Database Serverless also provides a built-in notebook environment and no-code user interfaces for AutoML, that's automated machine learning, and data and model monitoring. OML Services supports model management, deployment, real-time scoring, as well as monitoring and data bias detection using REST endpoints. And Oracle Data Miner, our first user interface, is a SQL developer extension with a drag and drop interface. Now, this is the Oracle Live Lab. You can explore on your own after this session, among others. And to get you started, Sherry's going to walk you through getting into OML notebooks. Sherry?
Okay. So this is my autonomous database in the Oracle Cloud Infrastructure, or OCI console. And the Live Lab instructions will show you, you'll navigate here through a URL and you'll log in using a username and password, and then you'll select your database. And that's where we are now. And here you'll find some of the database details, like the database version, the database name, which is OMLLA, and other information. From here, you're going to go from database actions to view all database actions. The first thing that you might want to do is create an OML user. This will be already done for you with your Live Lab, but I'm going to show you how to do that. Okay, so I'm logged in here as the administrator, admin. There we go. And I go to administration. And then we have the option under administration to go to database users. And I can create a new user here with this button. So I'm going to call this new OML user. This is a database user. I'll give it a username and a password. They need to match. Confirm the password. And then simply toggle the OML button. And then this user, if I were to create it, will have access to the OML user interface. Okay, so now we'll navigate to OML notebooks. We'll go back to database actions. Development, and Oracle Machine Learning. And then here is where I log in with my OML username and password. And your Live Lab will provide the credentials for you. And this logs us into the Oracle Machine Learning Notebooks interface. So here, under What's New, you'll get announcements from us. And quick actions, these are links to commonly used OML functionality. And there's a link down here to our Live Labs and documentation, getting started, how to create notebooks. And yeah, so this is how you access the OML notebook interface. It's very straightforward. You simply sign into your database through Oracle Cloud, either set up a new user or log in with your existing user, and then launch the OML UI. Okay, back to you, Mark.
Thanks, Sherry. So let's highlight a few more components and then demonstrate some. Now, OML Notebooks provides a collaborative user interface with built-in SQL, PL/SQL, R, Python, Conda, and Markdown interpreters. It provides a customizable built-in data visualizations as well. You can import and export Zeppelin and Jupyter notebooks, as well as explicitly share notebooks and templates. Conversion notebooks and schedule them to run at a set time or a recurring schedule. And you can use third-party R and Python packages in OML notebooks through custom-created Conda environments. We've also enabled using GPU compute resources with the Python interpreter and GPU-enabled packages configured through custom Conda environments with the higher eCPU compute capabilities for Autonomous Database. And as you see, OML Notebooks provides a library of template example notebooks illustrating various OML features. You can also schedule notebooks to run with email state change notifications like notebook completion. Now, if you want to use third-party packages on Autonomous Database, you can do that by creating custom Conda environments as the admin user. And this applies to both Python and R packages. The administrator installs the packages and saves them to cloud storage. And users can then download and activate those Conda environments from object storage. Now, the packages are then available for use within OML notebooks through the Python and R interpreters, as well as a feature called embedded execution for our Python and R interfaces. Where in the case of embedded execution, the database spawns Python or R engines to run user-defined functions. And these Python and R UDFs can be invoked from, of course, Python and R, but also from SQL and REST for easier use in applications and dashboards. So let's take a brief look at the SQL, R, and Python interfaces, starting with OML for SQL. OML for SQL enables you to build and evaluate machine learning models using the in-database algorithms from a PL/SQL interface, and then use those models in SQL queries. And this is supported through the DBMS data mining package. Each model provides what we refer to as model detail views that expose various aspects of the models, including quality metrics, various metadata, and the patterns that are applicable produced by each of the algorithms. Now, new to OML for SQL is the ability to use vector embeddings as input to several of our in-database algorithms. And to support the notion of bring your own model to the database, you can import ONNX format models, including text transformers, and in the latest 23.7 database, image transformers as well, for use in SQL queries using the in-database ONNX runtime. And such transformers are also used with AI vector search. Now, ONNX, or the Open Neural Network Exchange, is an open source representation of machine learning models. It works for models other than just neural networks. So despite its name, it's inclusive of many different types of models. Now, here's an example of building a classification model to predict customer behavior. In this case, whether they'll buy travel insurance. Using the DBMS data mining procedure create model 2, we provide a model name of buy travel insurance, which we can later use in SQL queries. The data is provided using a query. Here you see select star from customers, but it could be an arbitrarily complex query. And from our settings list, we specify the support vector machine algorithm. Our target column, that is what we're trying to predict, is buy travel insurance. That's in our table. And when we use this model, we can use prediction operators built into Oracle SQL. Here, we're doing a singleton score using the prediction probability operator on the buy travel insurance model. And we're providing the predictor values directly in the query. Of course, though, we could also perform large-scale batch scoring on all the records in a table and either materialize that result for direct access, or we could score dynamically using a view defined with that same model prediction operator that we used. Now, there are several other features of the in-database model, such as explanatory prediction details. And I'll just mention briefly that this allows you to identify which predictors contributed most to a given individual prediction. For example, in the first row of the result, the customer is predicted to buy insurance, and the predictor's year of birth and year's residence are the top two predictors for this customer. It also provides specific values and an importance weight relative for that particular customer. Now, one other feature I'll mention is what we refer to as partitioned models. Here, OML automatically partitions data using one or more columns and builds a submodel on each partition. All the submodels are provided to the user as a single unified model that can be used directly for scoring. The system determines which submodel should be used based on the values provided in the partition columns automatically. And this is beneficial to build more targeted models, for example, one per city or state, or perhaps customer segment. In some cases, model accuracy can be significantly improved for individual data partitions. So next, we'll highlight OML's native interfaces for the Python and R languages. Using OML for Py and OML for R, you take advantage of Oracle Database as a high-performance compute engine by using proxy objects and function overloading, where you can use familiar Python and R syntax for exploring and transforming data. The APIs enable using the in-database machine learning algorithms through native Python and R interfaces. And in the Python API, you also have access to automated machine learning, or AutoML. You can store and manage your Python and R user-defined functions and objects in the database, as well as invoke user-defined functions from SQL and REST using database-spawned and managed Python and R engines, as we mentioned earlier. You can also incorporate third-party packages into your solutions when invoking these functions. Now, to give you a clear idea of what we mean by transparent access and manipulation, we use proxy objects and overloaded functions to take advantage of database column indexes, query optimization, parallelism, and table-level partitioning. These can greatly improve performance and scalability on database table operations, since the data is not brought to the client engine when operating on them. Now, here we see how to create a table from a pandas or R data frame using the create function, specifying the table name we wish to use, in this case, Iris. And if the table already exists in the database, we can use the sync function and specify the table name that we want to access. Now, each of these returns a proxy object that we can then use to invoke familiar data frame functions like shape, head, and describe for Python, and even take advantage of Python syntax for splitting data into train and test sets. Similarly, we've overloaded R functions like dim and summary, along with dplyr functions. So these overloaded functions, in effect, translate desired functionality to SQL for in-database processing. Now, so we've already seen the PL SQL interface for building a model, but let's briefly contrast this with the R and Python interfaces. On the right, we get a data frame proxy object for the customer table. We set the model name to my travel insurance, and then build the model using the R function that invokes the in-database support vector machine algorithm. And we use the R formula syntax to specify the target and the predictors. We specify the proxy object customers and the settings. And below, that is the Python example. Again, we get a proxy object to our customers table. We can separate the predictors from the target, as is the Python convention, and create an SVM model object and fit it with the data and our desired model name. Now, each of these produces a model in the database that can be used from their respective interfaces, or, as we're showing here, through a SQL query and the prediction probability operator that we saw earlier. Now, as I mentioned a moment ago, you can store Python and R objects in the database. And using these functions avoids having to store native R and Python models in flat files. Instead, you can keep everything unified in the database with security, backup, and recovery already addressed for you. So let's look at OML notebooks in more detail and instantiate one of the template notebooks that uses OML for SQL. Sherry?
Okay, so each user begins with a personal workspace containing a project. And from there, you can create additional workspaces and projects and manage sharing permissions for team collaboration. And so here we're using the office hours project in my OML workspace. So let's navigate to our collection of template examples. And so we have, I think, over 150 examples here that you can search on, and you can either view or you can run them. So in the lab, there's they're going to point you to this OLMA for Pi classification DT. If I just wanted to look at this in read-only mode, I could click the title, but I'm actually going to instantiate a notebook that I can run from this. So I highlight it until we see that blue outline, select Create Notebook, and then it's going to create this notebook in my workspace. I press OK. Okay, and then I can open the notebook either from the Cloud menu, go to my notebooks, or I can open it here. I'll just go to my notebook listing. Okay, and here it is. I can open it, OM over Pi classification DT. This is for decision trees. So while the notebook's loading, and here it is, I can run the whole notebook by selecting this global run paragraphs. So I'll start that now. But I can run an individual paragraph as well. So each paragraph you'll see has its own run paragraph arrow. And let's see, I have versioning capabilities. I want to have different versions for my notebook. I can clear all of the output in the notebook if I want to. We have the ability to create paragraph dependencies. And so if you've done that, you can clear the paragraph dependencies. You can export this notebook in the native format, which is Oracle Data Studio notebooks or Jupyter format or Zeppelin, and you can print the notebook. Each notebook is associated with a service level, and this is the low service level, but we have medium, high, and GPU. And what that means is that corresponds to database parallelism. So low is going to give you the least amount of parallelism and concurrency, and high gives you the most, and then GPU allows you to work with GPUs. Okay, so going through the notebook, we can run some of these paragraphs. We have some documentation that you can click on and look at. We're going to import our Pandas library and our OML library. That corresponds to Oracle Machine Learning for Python. Ignore the warnings, and then we're going to sync a table to a proxy object. So our supplementary demographics table to what we call a proxy object, and that's going to be the way that we interact with our database data. Display the number of rows and columns, so the shape. And so we can, use this notebook to interact with our database data using these Python interpreters. Now, we also have, in addition to Python, we can add paragraphs here. If we want to add an R paragraph, a markdown paragraph, or we want to put an image in there or some explanatory markdown, a script paragraph. So this is PL SQL. Okay. That will run PL SQL. We also have the ability to add a conda paragraph in here for third-party, for using third-party libraries. If we want to add some notes to a paragraph, another option, you could do markdown, but you also can comment on a paragraph. So just like that, very easy. You can delete the comment, edit the comment, but once the comment is there, you get that green indicator, and you can take a look at that comment. You can also, another thing that you can do, go back to our notebook listing, is you can import a notebook from your hard drive. I've saved one here. This is an OMA for Pi data cleaning outlier removal. So you can import that from your hard drive, and that's another way to get a notebook into this environment. So we have this collaborative workspace environment, and you can use, Mark mentioned Python, R SQL, PL SQL, Conda, and you can leverage our pre-built templates. We have version control, very flexible import and export capabilities to streamline your workflows. Okay, back to you, Mark.
Sherry. So, before talking about automated machine learning, or AutoML, I'd like to illustrate the machine learning model process that a typical data scientist might go through as motivation. So, data scientists typically have access to multiple algorithms to choose from for a given use case. We showed many of them that we have in OML itself, just for classification or regression, among others. But the question is, which should be tried? Which is going to produce the best result? So we start with one algorithm, perhaps SVM, build a model using the default settings or hyperparameters, and we might even tune those hyperparameters to hopefully improve model quality. Then we're going to compare each model against the previous models, selecting the current best model. And then we repeat this process with the next algorithm. Well, this is an iterative and trial and error approach, and it can be expensive, both in terms of time and even compute resources. It also requires that you understand how to tune each of the algorithms to produce a better model. And, as I mentioned, one of the features of OML for Pi is automated machine learning. And this simplifies the modeling process for you. Now, AutoML supports automated algorithm and feature selection, as well as automated model tuning and selection for classification and regression. Now, the goal is to obviously enhance data scientists' productivity and help non-experts produce reasonable machine learning models. It eliminates the repetitive and time-consuming task of building and evaluating models, and users don't need to understand how to tune individual algorithm hyperparameters. Now, here we see the API, starting with algorithm selection, where the top-N algorithms are ranked. And in this example, for classification, we're using a wine data set. We follow this up with feature selection, where in this case, we're taking 13 columns that have been reduced to 9 for the previously selected algorithm of SVM Gaussian. And then model tuning, which optimizes the hyperparameters for the selected algorithm and the selected features that you've produced previously. And when you're finished, you have a model that you can start using if it meets your requirements for the accuracy metrics that you've set. Now, OML also supports AutoML in the form of a no-code user interface. You select the prepared database table and the column you want to predict, specify a few optional details, and click Start. The AutoML UI builds and compares multiple models with model quality metrics provided. And you can also generate notebooks for individual models that provide the AutoML determined hyperparameters. Through this no-code user interface, you can also deploy individual models to OML services, which I'll say more about in a moment, for use through REST endpoints. Of course, once the models are produced, you can immediately use them through SQL queries as well. So let's get a quick demonstration of the AutoML UI and generating a notebook for one of the models. And this starter notebook, as you'll see, uses the Python API. So Sherry, back to you.
Okay, so let's go to the AutoML UI from this cloud menu, go to AutoML experiments, okay? And so I already have an experiment that I have run here. And so what you do is you give it any name that you want, and then the data source, either from your schema or a schema where you have select access to the data. I'm choosing, this is a drop-down menu, I'm choosing the variable to predict is credit score bin, that's my target. The classification is chosen automatically depending on the data type of the predictor, and then my case ID for reproducibility. I had chosen customer ID. And under additional settings, I can, the default here for the maximum number of top models is 4, but I reduced it to 3. And I chose the database service level as high. You can change the model metric from the default, and you can also reduce, the number of algorithms to search if you don't want them all. Shows you the features that from the data set, their data types, and then select Start, and you can choose faster results or better accuracy. And faster results is trying fewer pipeline combinations, where better accuracy will try more pipeline combinations. And those consist of data algorithm and settings. So as this experiment runs, you'll see on the right the progress bar and the workflow steps. They're going to get checked off as they complete. And the leaderboard, which make sure you can see that, will start to populate as this as the algorithm selection is happening. Okay, so that has already run. I'm going to go over and show you how to create this from scratch. Create, you put in your name. You can have a comment. Data source we already went through. We're going to predict. And customer ID. Remodels, medium, faster results. So this will take a few minutes. You'll see the steps that it's going through. Right now it's completed the algorithm selection. Then it will go through a feature selection and then model tuning. And when it's done, we can take any of these algorithms. They have an internal model name, and we can create a notebook that shows how this model was built. Let's give it a few more minutes. So the feature selection is completed, and now the model tuning is going. And you can see these metrics start to populate. This will just take another minute or two, and then we can take a look at the notebook for the top model.
Hi, Sherry. While we wait, do you mind if we answer a quick question that popped up in chat?
Yeah, sure.
So JJ Nukes asks, so is this is part of what someone working with machine learning at Oracle would use?
Yeah, we have people internally using the AutoML UI, but you can also use the notebooks and with code directly.
Awesome. Yeah, I just wanted to pop that in there. There might be some other questions that pop up, but I'll jump back on if anything does come up.
It should just be one more minute. Okay. The last step is the feature prediction impact to show us which features in our data set most contributed to these predictions. Okay, so the experiment is now completed, and this is our top model. So here's the model name, and you can see the prediction impacts are wealth and customer DMG segment, and we have a confusion matrix. And then to create the notebook, I just select the model, go to create notebook, and it already has a default name. And this will be an OML notebook running the Python code that was used to build the model in the background. Oops. Let's try that again. the notebook. And this will open up in our OML notebook listing. We can run it. It'll be a notebook that we can run, and we can edit the notebook, augment it with anything that we want to. So notebook's loading. Another thing to mention, I'll run the notebook while I'm explaining this. You can take these models that are produced from experiments and you can deploy them. Well, you can run them directly through SQL queries, okay, or and you can also deploy them to OML services, but you can deploy them through SQL queries with your enterprise applications. So anything that runs SQL, Oracle Analytics Cloud, Oracle Apex. There we go. So this notebook is generated. It says that it's generated from the AutoML UI. We're creating that proxy object from our database table so we can interact with it. The training data. We built test and train data. Here's where we're building the model. And the important thing here is that we have all of the model hyperparameters that were chosen during the experiment run. You can see those here. The model details. And scoring. There's the data for scoring. We're running predict, and then the model quality metric. Okay, back to you, Mark.
Okay, thanks, Sherry. So just to highlight also that the question about interfaces and how you can work with machine learning on Autonomous Database or Oracle Database, you can also connect directly to the Oracle Database from your favorite IDE. So whether that's SQL Developer, Jupyter Lab, RStudio, or other interfaces that you'd like, you can set those up to be able to connect to the database and work directly with those interfaces. All right, so what I'd like to touch on a little bit further, so Sherry alluded to this as well, that we have the ability to deploy models to OML services. And that provides MLOps support on Autonomous Database Serverless, where you can manage and use machine learning models from REST endpoints. And this includes model management, deployment, data and model monitoring, as well as data bias detection. Now, on the scoring front, OML Services provides lightweight scoring using REST endpoints, making it appropriate for real-time and streaming applications. And not only can you deploy in-database models in native format, but you can also bring your own ONNX format models, perhaps produced in third-party environments, and import them into the database for use through the same REST API. And for this, OML Services supports classification, regression, clustering, and feature extraction models. Now, in contrast with other machine learning model deployment approaches, it's important to note that with OML Services, you're paying only for the actual scoring compute. You don't have to provision a separate VM and manage and pay for that VM 24/7 to support your application. That's provided by the Autonomous Database environment. Now, on the theme of bring your own model, you can also import text and image embedding models into your 23AI database. And these can be used in combination with AI vector search. Using the OML util package from OML for Pi, you can easily generate a portable ONNX format model from a Hugging Face repository and save this model to the database for use with the in-database runtime. And there's also a PL SQL interface through the DBMS data mining package. Here, you provide a pre-created ONNX format bundle to import to the database. We can say it's a bundle because there are certain pre- and post-processing steps that are required to use your model in the database. Now, to put this in context, here's a quick example of how to use such imported transformers for document similarity search. Consider that we want to get the top 10 job posts for a software engineer in New York, ordered by the resume's semantic relevance. Well, we take a text document, convert it into one or more vectors, and search our vector database to retrieve the relevant job posts. Let's look at the simplified code for doing this using AI vector search. We first need to create our table of vectors, and we'll use the vector embedding operator and our sentence transformer model to create an embedding for each job post. There are more sophisticated ways of chunking documents, but we'll keep it simple here. Next, we create a vector index on our newly created vector column embedding. And then we can write a SQL query that allows us to combine the structured data filtering with the vector distance operator, where we pass in our resume text and produce the vector embedding and compare that against the embeddings in our index to find the most relevant job posts. And of course, we're using the sentence transformer that we just imported into the database that I showed in the previous slide. Now, in addition to embedding models, you can also import classification, regression, and clustering models to use the in-database ONNX runtime. Such imported models behave like a native in-database models and can take advantage of the same prediction operators in SQL. In this example, we retrieve the ONNX format model from object storage and import using the import ONNX model procedure to store the model in the database. Then we can use a SQL query and the prediction operator to use our new model, in this case, a churn model. Now, also available through OML notebooks are the OML for Pi spatial AI ML algorithms. In addition to traditional spatial analytics, you may want to use such data to identify maybe where crimes are clustered in an area or unemployment hotspots. As you see, some impressive visualizations are possible with the results. Now, spatial AI has a variety of machine learning techniques and corresponding algorithms to work with spatial data directly in your database. And there are some template example notebooks that you can browse to understand more about the specifics of using this API. So to summarize, you have a lot of capabilities with OML notebooks, and being part of the database, the machine learning functionality is immediately available to you. And on Autonomous Database, there are a wide range of built-in tools at your fingertips. You can avoid moving data and use multiple language APIs, including SQL, Python, R, and REST. You can take advantage of AutoML and scalable modeling, leveraging elastic scaling on Autonomous Database. In addition, you have flexible options for development, test, and deployment, whether you're on the cloud, on premises, and hybrid environments. So with support for multi-cloud environments, you can also operate not only in the Oracle Cloud, but also Azure, Google, and AWS. So for more information, here are a few resources. Check out our machine learning blog. There are live labs where you can spin up an autonomous database easily, as we've mentioned already for this lab, and try out the features that we've talked about, as well as product documentation. So thanks for joining us for this session on Oracle Machine Learning. And if there are additional questions, we're happy to take them now.
Awesome. Thanks, Mark. Thanks, Sherry. We do have a couple of questions. I know that someone earlier asked if they could see the best model metrics from one of your demos. Alternatively, if you can't, bring up the workshop, bring up the live lab, you could just take a screenshot of it maybe, and I can drop it into the channel for you. Another question we had was, if I saw the scores correctly, very possible that I didn't. It looks like all the models tied in terms of balance accuracy score. What would you do in that case?
Well, one way of looking at that has to do with the type of model that was used, or the algorithm that was used. Different algorithms have different performance characteristics and different transparency. So for example, you might not be able to understand what a neural network is doing, but a decision tree that has comparable accuracy can give you human interpretable rules, and you might find that useful. Or maybe a support vector machine that provides coefficients for individual predictors so that you can understand that as well. So the fact that they come out relatively tied is actually fine. It's just decide which algorithm you might like. One other consideration has to do with the performance aspects of models. Some are much faster than others for scoring. And depending on the volume of scoring that you're doing, you may want to choose one over another. So those are just a few considerations.
Awesome. Thanks for that answer. Really appreciate it. I'm sure the folks at home appreciate it as well. JJ Nukes asks, it's a little bit unrelated, but what would Oracle look for in someone like me, a computer science bachelor student interested in machine learning and AI, when they are looking for an internship or first out of college job?
Well, that's an interesting question. In terms of what would anybody be looking for from that? Do you have experience in working with data and solving interesting problems? What types of things have you done, say in university or previous positions? And what is it that you're looking to do? I think that's one of the key things, is to have a clear idea of what it is that you'd like to accomplish going forward in your career, and then bring that to the table. And that can actually be a really significant influencing factor.
Awesome. And I know a lot of folks out there are really curious. In the previous workshop that we covered, there are certifications that you can earn on the Oracle website. Going through some of these live labs will probably give you a good idea of what those certifications entail. So if you're interested, the link is there in the chat. Looks like that's all the questions and time we have for today. One last one, I think, is coming from someone from the Oracle team. Just a comment. Did you do a hackathon project? POC, that was awesome to show as an example, I think, is another way of answering part of that question from JJ and Oops as well. So yeah, great insight there. And lastly, I just want to thank you, Mark and Sherry, for coming in and joining us today. Such a great session, and always great to have people from the Oracle team come in and join us. Once again, folks, if you want to grab any of this information, we'll try to get the slides uploaded to Discord for you. Take a screenshot of these links here so that you can have them for later if you don't want to wait for the slides to be uploaded. But outside of that, yeah, thanks once again, Mark and Sherry. Thank you for your time. Really appreciate everything.
And thank you as well.
Thank you.
All right, yeah. All right.
Take care now.
Have a good one, y'all.
Bye-bye.